So now that we kind of know what a 3D vector looks like, we can actually look at some of their properties. Now all the properties we talked about for 2D vectors really work in 3D. So for magnitude, instead of having just two components, we'll actually have three things squared and added together. Same thing for this magnitude, so I just have vectors A and B. If you want a dot product of these two vectors, we just multiply the x's, multiply the y's, multiply the z's, and add them together. And then since we have a dot product and we have magnitudes of these vectors, the same angular formula works as it did before. So the cosine of angle theta will equal the dot product of the magnitude of A times the magnitude of B. So we kind of like that nothing really changes, everything kind of follows the same pattern. So let's look at these two vectors and kind of work with these. So we have vector A is 2, 1, 0, and vector B is -3, 2, 4. We want to find the angle between the two vectors. So obviously, to do that, we're going to have to set up cosine theta equals A dot B over magnitude of A, magnitude of B. So we have to find those three things. So let's find A dot B. So A dot B is going to be 2 times -3 plus 1 times 2 plus 0 times 4. So that's -6 plus 2, so that is going to be -4. So that's our dot product. So over here, cosine theta, we know the top is going to be -4. So then we just have to find the individual magnitudes of these vectors. And same thing we said, it's still the square root of the component squared, there's just 3 of them. So the magnitude of A is square root of 2 squared plus 1 squared plus 0 squared, which is square root of 5. The magnitude of B is going to be the square root, and with this -3, I'll make sure I put that in parentheses to make sure it gets positive. Is going to be -3 squared plus 2 squared plus 4 squared, which is 9 plus 4 plus 16, which is 29. So this is square root of 29. So over here in our cosine ratio, we know this is radical 5, this is radical 29. So this is going to be -4, and then I can, of course, do 5 times 29 in radicals and get 145. So that's my cosine ratio. So my actual angle between my vectors, I'll simply take the inverse cosine of that ratio. So the inverse cosine of -4 divided by the square root of 145 is going to yield 109.4. So if you graph these two vectors, the angle between them should be 109.4. Now obviously in 3 dimensions, when you're drawing it on a 3D graph, that would be really, really hard to do, hard to visualize. But if you were to actually graph these in space, this would be the angle between them.